Today we're going to finish up our graphing linear functions lesson. So you're going to be in your notebook on page 41. We're going to glue in a foldable here. Of course, if you don't have a printer, you're just going to write on page 41. The title for page 41 is 5.1, Graphing Linear Functions. That's the title. Maybe you should keep those somewhere so you'll pass this notebook test this time. You will not be able to take it more than once. Okay, so if you have a printer, though, you printed out the notes. Linear functions. We're going to be talking about linear functions again today. However, us talking about linear functions today, we're going to talk about it in different types. So there's quite a few different things to get understanding of or to understand. Yesterday, we talked about lines in slope-intercept form, and that's y equals mx plus b. That's the one you've probably heard over and over and over again. There's another one called point-slope form. We'll talk about that one today. Y minus y1. That just means the actual point y equals m slope times x minus x1. So it's literally a point and the slope of the point is x1 comma y1. The slope is m. Okay, let me zoom in a little bit on this. The slope-intercept, slope is m, intercept is b. Right? And then standard form is not something special like this. Standard form is ax plus by equals c. And that's just where a, b, and c are whole numbers. Okay, so we are going to learn how to graph things in standard form first, then we will move on to point-slope form. Okay, number one is in standard form. We're still going to list all of the same things, okay? We're going to draw a nice line down here because we're going to need it to find the x and y intercepts. And we're actually going to find the x and y intercepts to graph. So the x-intercept, the y-intercept. We're going to find those to graph. And here's how we find them. The x-intercept means y is 0. So here's what we're going to do. If y was 0 right here, that means negative 2y would go away. So to find the x-intercept, we're going to cover up the y and have 3x equals 6. We're going to write that down. 3x equals 6. Solving this will give us our x-intercept. So divide by 3, and x equals 2. That means our x-intercept is 2, 0. 2, 0. We will do the exact same thing to find the y-intercept, except for the y-intercept, x is 0. That means this 3x would go away, and we would be left with negative 2y equals 6. Okay, now we'll solve this one for y. Divide by 2. Y equals negative 3. That means our y-intercept is 0, negative 3. We will find the rest of this after we graph it, okay? After we graph it. So far we have the x-intercept, which we found right here. And we have the y-intercept. Which we found right here. We did that by making the y 0 and then the x 0, x0, y 0. All right, so let's graph these 2 points. I have 2, 0 right here. That's the x-intercept. And I have 0, negative 3. That's the y-intercept. I'm going to use my straight edge to connect these. Having these intercepts, I'm going to be able to find the slope. My slope is rise over run. I'm going to go up 3 over 2. 3, 2. My slope is 3 over 2. I can also find that in the formula. The slope can be found by doing negative a divided by b Negative 3 divided by negative 2 is 3 over 2. That's another way to find the slope in standard form, or just using or looking at the graph. All right, let's talk about in behavior. Remember, when x goes to the left, or the negatives, and x to the right, what is y doing? Okay, so in the left side over here, when x is going towards the negative numbers, y is going down as well. So that means it's negative infinity. Okay, on the right side, it's going up, so it's positive infinity. Did not change, they're still linear, so the domain and range, because it's pointing in both directions forever, is all real numbers. Okay. All right, we're going to do a couple more standard forms before we talk about point slope form. So open this up and let's finish those. Okay. So we're first going to find the slope actually on number 2. Then we'll do the x-intercept, the y-intercept. We'll graph it, make sure our slope's really correct. Then in behavior, domain, and range. So slope, I told you guys we could actually do negative a, so that's 2, divided by b, 1. So that's negative 2. So we'll check and see. That's the slope. Okay. Then we're going to find the x-intercept and then the y-intercept. X-intercept, y-intercept. And I'm kind of out of some room. That's okay. X-intercept. Cover up y. I would have 2x equals 4. Divide by 2. X equals 2. So my x-intercept is 2, 0. You have to make sure you put it in a coordinate point. You will lose points on your quiz if you don't. Actually, the computer makes you put in a coordinate point. All right, y-intercept, cover up x. Y equals 4. Hey, guess what? We really lucked out on that one because we don't have to even divide anything. So it's 0, 4. Okay, now let's graph. X-intercept 2, 0. Y-intercept 0, 4. We're going to check our slope as well, just to make sure we did it right. Okay, now let's check slope. I went down 4, right, 2. That's negative 4 over 2, which is the same as negative 2. So we did do that right, good. All right, in behavior, when x approaches negative infinity and when x approaches positive infinity, what does y do? Okay, so I'm going to cover up. On this side, it is going up, so it is positive infinity. On this side, it is going down, so it is negative infinity. Domain and range all week long is all real numbers. Lines always are all real numbers because it's pointing in both directions. Okay? I want you to pause the video and do 3 and 4. 3 and 4 are all standard form. You need to pause it and try those on your own. Okay. X-intercept and Y-intercept, and I'm going to see if I can fit them here instead. And I'm going to go ahead and find the slope too, first actually. All right, remember the slope. I can do negative a, negative 1, over negative b, negative 1. That should be positive 1. Okay, x-intercept, cover up y, and I'm left with x equals 5. I didn't have to divide that time either, so it's 5, 0. Y-intercept, cover up x, negative y equals 5. This is not okay. I cannot have a negative value, so I need to divide by negative 1. That means y, or the y-intercept, equals negative 5. 0, negative 5. Okay. Now let's graph. Got to move that up so you can see. 5, 0, and 0, negative 5. I'm hoping my slopes are right, but we'll see. We'll check it. It's a good idea to always check it. Let's see. Rise 1 over 1. That's right. Up 1 over, up 1 over, up 1 over, up 1 over. That is correct. The slope is 1. Okay. In behavior, when x goes towards the negatives and when x goes towards the positives. I wrote that in domain. Whoops. When x goes towards the negatives, when x goes towards the positives. What does y do? Okay. Right here, when x is going towards the negative value, so is y. It's going down, so it's negative infinity. On the right side, it is going up, so it's positive infinity. Okay, and domain and range are all real numbers. If you did not already do number 4, which I will show you, you need to pause it and do it now. All right, let's find the slope first. Slope is negative a, negative 5, over b, negative 4. That is 5 over 4. X-intercept. We cover up y. We're left with 5x equals negative 20. We divide by 5. We get x equals negative 4. Negative 4, comma, 0. By the way, I could actually go ahead and graph this now. I'm not going to, but I could. The second you get two things, as long as you have slope and a point, you can always graph. Okay. Y-intercept. Cover up x, and I have negative 4y equals negative 20. Divide by negative 4. And y equals 5. So 0, comma, 5. And I will graph these 2 points, or one of these points in the slope. I'm going to graph the 2 points. So negative 4, 0 is here. 0, 5 is here. I'll check the slope, though. Always check your slope. Use a straight edge, all that stuff. Okay, it is going up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So my slope is correct. We're good. In behavior. What is y doing? Okay, when it goes towards the left, it is going down. When it goes towards the right, it is going up. In case you haven't noticed on these, if it has a positive slope, x and y match. If it has a negative slope, they're the opposites. I don't know if you've noticed that or not. Domain is all real, so is range. All right, we're going to do 5, 6, and 7. 5, 6, and 7 are point slope form. I could not think of the word point slope form. What that means is I have a point x1, y1 given to me, and it's given to me right here. The point is actually, for this, it's not negative 2 because, so let's look at this for a minute. So the point x1, y1 comes from here. Here's the x value, here's the y value. Now when I put it in here, I put the opposite, and here's y. This is a minus, and this is a minus, but notice how these are pluses, so I put in the opposite sign. So on number 5, the point is 2, comma, 1. Okay? That means when I graph it in a minute, my line should go through 2, comma, 1, so I'll be able to check that in a minute. But let's start by finding the slope and the x and y intercept. And we're going to solve for x and y intercept kind of like we did. It'll be a little weird, a little different. Not weird, just different. And I'll show you what I mean by that in 1 minute. So let's look at the slope first, though. In point slope form, the slope is given to you right there. So it's right there. The slope is 3. Okay, over 1, because we will need that in a minute. But we're going to find the x and y intercept next. Okay, the x-intercept. Solving this is a little different. what we actually do is not completely different, all right? When we had the x-intercept, we made the y 0, or we covered up y. So we have -1 equals 3 parentheses x minus 2. So the process of solving will be different. However, the actual, what we did to get an equation is not different. So we are going to distribute -1 equals 3x minus 6. Okay. Add 6. We're going to run out of room. So that's 5 equals 3x. Divide by 3. And x equals 5 over 3. We're not going to want to graph with that, because I don't know where 5/3 is, but that's okay. I do, but we're not going to estimate. We're not going to do that. Okay, let's do the y-intercept. Okay, same process, but now I cover up x. So I have y minus 1 equals 3 times -2. The x just goes away there. It doesn't go away, it becomes 0. And 0 minus 2 is -2. So don't think it's just going away. Kind of like this right here. It wasn't, y didn't go away. It was 0 minus 1, which is -1. All right, so let's solve. Y minus 1 equals -6. Add 5, add 1, and you get y equals -5. I was telling you the answer. So the y-intercept is 0, -5. Okay, I'm going to do things a little differently. A minute ago, I graphed with these two. I don't want to graph with 5/3, 0. So I'm going to put 0, -5 on the graph. And then I can either go up 3 over 1, or I can graph 2, 1. Either one is appropriate. I can put 2, 1 on here and draw a line, or I could go up 3 over 1. Either way, see if I went up 3 over 1, there's that point. I can do any of those options there. I just have to have 2 points to make a line. Then we will talk about the rest of this. Okay, there's our graph. 2, 1 is on that line. Okay, now let's do an end behavior. Okay, when x is going towards the negatives, y is also going towards the negatives. Positive slopes, so they match. X is going towards the positives, y is going towards the positives. Okay, domain and range are all real numbers. Okay, I'm going to kind of, there we go, got my space back. Number 6. Our slope is 6. Our special point is 1, 2. That means 1, 2 is going to be on our line. I could graph it right now by going up 6 over 1. Okay, but my slope is 6. Let's find the x-intercept and the y-intercept. X-intercept is -2 equals 6 times x minus 1. Distribute 6, so -2 equals 6x minus 6. Add 6. I have to write it right over here. 4 equals 6x. Divide by 6. 2/3 equals x. So again, I'm probably not going to want to graph that x-intercept, but it is 2/3, 0. Give myself some room there. I don't think I need that much room though. and the y-intercept. Y minus 2 equals 6 times -1, because 0 minus 1 is -1. Okay, y minus 2 equals -6, add 6, add 2, not 6, add 2, y equals -4. You can't see that. 0, -4. Okay, I'm going to graph it and then talk about the other pieces. So I'm going to put 0, -4 on the graph. I can either, I've already got 1, 2 on the graph, so I can graph the y-intercept and go up 6 over 1, but up 6 over 1 is actually 1, 2. So I'm just going to connect these 2 points. Got my graph, so I can decide about end behavior. When x approaches -infinity, and when x approaches +infinity, y is going towards the negatives, so -infinity, and then on the right side, y is going towards the positives. Domain and range are all real numbers. It's a lot in these problems, and I know that, but we are going to do this for every single type of function. So we're going to just get in the habit of doing all this kind of stuff. All right, our slope. Pause this and try number 7 on your own. Our slope is 1/3. Our special point is -3, 1. It's -3, 1 because we do the opposite and the opposite. I'm going to graph that point. -3, 1. See, I can graph it right now. Put the point, go up 1 over 3, right here. I can do it without finding the x and y intercept. By the way, you know what this also means? I can look right here and find the x and y intercept. We'll make sure it's right, but I can do that. Meaning right here is the the y-intercept, and right there should be the x-intercept. But we're going to see, make sure it's right. So let's write it just to see. Our x-intercept should be -6, 0. Our y-intercept should be 0, 2. This only works if it's on a whole number intercept. But let's see, did it really work or not? X-intercept is -1 equals 1/3 x plus 3. Distribute. -1 equals 1/3 x plus 1. 1/3 times 3 is 1. Subtract 1. -2 equals 1/3 x. And in case you forgot, you multiply by the reciprocal, which is 3 over 1, but 3 over 1 is just 3. So 3 times -2 is -6. Guess what? It worked. Y-intercept. That only works if it's a whole number. If it's not, you don't want to be guessing. All right, y-intercept, y minus 1 equals 1/3 times 3. So y minus 1 equals 1/3 times 3 is 1. Add 1. Y equals 2. That worked as well. It's pretty cool. All right, in behavior, as x approaches -infinity and as x approaches +infinity, what is the y doing? Y on the left side of this graph is going down. Y on the right side of this graph is going up. The domain and range are all real numbers. Like I said, I know it's kind of a lot at first, but that's okay. You're just going to keep getting better at it and doing well. All right, this goes glued to page 41. Here's the title again if you need it. Remember, if you don't have a notebook, just grab some paper. Write down that it's page 41 and it's 5.1. I don't care if your notebook is just a collection of pieces of notebook paper as long as you have it. You need to be keeping that somewhere. There we go. Tomorrow we'll talk about creating linear functions. I will see you then.